In this video, we're going to look at examples 5 and 6 from the compound interest notes. So for number 5, we are going to borrow $4,000 to pay tuition. We're going to finance it for 15 months at 8% compounded quarterly. How much will you have to pay the bank in 15 months, and how much interest will you pay? So once again, we have to figure out the correct formula to use. So if we go to our formulas for compound interest, there are 3 formulas. Notice it says compounded quarterly. It's not continuous interest, so this one's out. And notice we're borrowing $4,000. That's going to be the principal. So we know the principal. We want to know how much we have to pay the bank back in 15 months, so we're looking for future value. So if you know the principal and need the future value, this is the formula you're going to use. Okay, so I'm going to take a second and write that one down. Okay, so we want to make sure we have everything we need for the formula. I have the principal. Remember, I is periodic interest rate. It's R divided by M. That's on your formula chart. R is my rate, but I do have to change it to a decimal, so 0.08. And notice we're compounding quarterly. Quarterly means 4 times a year, so M is 4. I'm not going to necessarily calculate what that is. I'm just going to plug it into the formula that way. Now we also need N. N is M times T. Now we know that M is 4, but we have to be careful with our time. Our time is in months, so if we do 15, we're going to get 15 years. So for our time, we need to take the 15 months and we're going to divide it by 12 because there are 12 months in a year. And if you simplify that, you don't have to, but it comes out 1.25. And that makes sense because 15 months is going to be 1 year plus a quarter of another year. All right, so I'm going to plug that into my formula over here. And that actually comes out to be 5. Okay, so I'm ready to plug into the formula. Now remember, for credit on exams, you have to show the formula, the plugged in values, and the answer. All right, so for I, I'm going to do 0.08 divided by 4. We calculated N to be 5. And when you plug it in, to get it in your calculator correctly, we need to make sure we keep that set of parentheses. All right, so if we go put that into the calculator, see if I can get a good angle on that where you can see it. 4,000, parenthesis, 1 plus 0.08 divided by 4. Close the parentheses. Remember this caret button, the little arrow, that gives you the exponent, and we raise that to the 5th power. All right, so future value, $4,416. When we go to 2 decimal places, notice that's 3, so we're just going to cut that off at 0.32. All right, so that's going to be our future value. So $4,416.32. It is money, so you need the dollar sign, and you need it rounded to 2 decimal places. So that took care of future value. We were also asked for interest. So just like the previous problems, it's going to be the future value minus the principal. Okay, so we take our future value from the last problem. We're going to subtract off the principal, and whatever the difference is how much interest we paid. Okay, so for this problem, it's going to be $416.32. All right, so looking at number 6. Number 6 says, what lump sum should be deposited into an account that will earn 9% compounded monthly in order to grow to $300,000 for your retirement in 10 years? Notice this is a little different. We want to know how much money to put in so that in 10 years we'll have this amount. So this is going to be in the future, so this is future value. So we want to know how much money do we need to start with now so that we'll have that in 10 years. So the lump sum is actually the principal, and we don't know that. Okay, so here's our rate. Monthly, M is going to be 12, and our time is in years, so it's okay there. But so if we go to our formula chart to get the correct formula, here are our 3 formulas for compound interest. It's not a continuous interest problem, so this one's out. But remember, this one was backwards because we knew the future value and we needed the principal. So now we're going to use this formula. This is kind of a rearranged version of this one. So I'm going to take that formula and I'm going to copy it down for number 6. So P equals our fraction. We're going to do S over 1 plus I to the n. So notice it's got all the same pieces as the other formula. So we know S is our future value. So S is going to be 300,000. I is going to be R over M, which is our interest rate, 0.09 divided by 12. And then remember that N equals M times T, which will be 12 times 10, or 120. All right, so when I plug this into my formula, I'm going to get 300,000 on top. On the bottom, 1 plus 0.09 divided by 12, all raised to the 120. When you plug this in, make sure you get these parentheses right here. All right, so let's give it a try. Okay, so I'm going to put in my numerator first, divided by parenthesis 1 plus 0.09 divided by 12. Close your parenthesis. Then you're going to raise that to a power of 120. Okay, so you always want to make sure that you know how to put these into your calculator. Now remember, this should be a smaller number because we want to know what we need to start with that will grow to be 300,000. So we're expecting this to be less than 300,000. Okay, so we end up with a principal of $122,381.19. So that's how much money you would need to start with so that in 10 years it would have grown to 300,000.